Hi guys. Yes, how are you? Eng Steve Electric. Subscribe, comment, share. Today I have come with the topic is here. Introduction to almost zero. Are you having a problem with almost zero? Calculation, what? Subscribe, don't miss out. We are just starting almost zero, and by the end of this topic, you will be able to calculate almost zero. Most especially those who are still doing physics, engineering, doing electrical installation. Also, there's almost zero. Yes. What is almost zero, by the way? Almost zero. Almost zero is a formula used to calculate the relationship between, I repeat, subscribe, comment, share. Almost zero is a formula used to calculate the relationship between current, voltage, and resistance in an electric circuit. Yes. Now they are going to say, how the almost zero stated. It states that the amount of electric current, the amount of electric current flowing through a conductor is directly proportional to the voltage imposed on it. I repeat, subscribe, share, like, comment, so that you don't miss more video about almost zero, because I'm still uploading. I'm just the introduction. Well explained. I said that the amount of electric current flowing through a conductor is directly proportional to the voltage imposed on it, which means that 1 volt of pressure is required to push 1 amp of current through 1 ohm of resistance. The almost zero means that 1 volt of pressure is required to push 1 amp of current through 1 ohm of resistance. You are going to see here. We are going to use these 3 formulas to calculate the current, resistance, and ohm. Just subscribe, comment, share, like, then you don't miss. I'm just starting. Well explained. I told you, I'm the master of masters. Subscribe. Okay, we are going to do this thing together. I have here 3 pyramids or triangle. Call them the way you want, provided you will be able to master them. I'm going to call them pyramids. Now we are going to bisect them into 3 portions. This is like that. That one is done. Like that. Like that. Now, remember, current, the symbol is that one, capital I, measured in amps. Then voltage represented by V or E, measured in volts. Then resistance, represented by R, measured in ohms. You get it? This with the almost zero, you have to master current, voltage, resistance. Knowing those 3, electricity is done, or physics, whatever. I don't mind the level you are. You may be O level. Also subscribe. Doing electrical installation science, subscribe. Doing engineering, also subscribe. So here I'm going to use my I as current. Here I'm going to use V Here I'm going to use R. Right, even the same thing here, V I R, V I R. Now you are going to start our formulas. Now you may say, I want to find the voltage, which is therefore now we are finding the voltage. This is voltage. Voltage equals, you cancel this one. You have remained with the I, then R. You may say that is I R, or I in amps times R in ohms. That is voltage. Now the voltage is current times resistance. Then you want to find current, you close, that is current equals, that is V divided by R. You get it? Now you want to find R, that is R equals V divided by current. You get it? That is it. So these are three formulas. With almost zero, you are done. So you have to master the three pyramids. Or you may also, if you have some clue about it, or you have some knowledge about it, you can use one. So I have used the three so that I show that here I have cancelled the volts, here I have the voltage, here I cancel the current, here I cancel the resistance. So now I'm going to put there some example to show you the calculations. Subscribe, comment, share, like. Yes. I have here an example. We're having here an electric circuit. It's having a battery of 24 volts. Then we're having a bulb of 6 ohms. Now we want to know the current in that circuit. We have to calculate the current in that circuit. So as I told you that we are going to use the other pyramids where current equals, that is voltage over resistance. That's the formula for current. As I told you in the other pyramids, the way I called them pyramids. You may call them the way you want. Just subscribe. I don't want you to miss the content about Ohm Zero, because I'm going to explain it very well. Just subscribe, share, comment, like. Now here we are having we don't have the current. That is current equals, what is our volt? That is 12 divided by 6. You get it? That this is our voltage is 24 divided by 6. Now we are going to cancel. Therefore our current equals 12 divided by 6, that is 4. 60, that is 4 amps. So here the amount of current in this circuit is 4 amps. Now we may also find you may also find the voltage, resistance, once you have these two, once you have voltage and resistance, you'll be able to find the current. Now that is the first example. This is the first example of finding the current in the circuit. Now we are going to find the resistance. I'm going to use another example. Yes, another example is here. Now here we have the voltage, we have current. Now we are looking for resistance. The first example, we are looking for current. Now we are looking for resistance. Here, the solution is here. Let us start. Remember, resistance equals, I think you still remember the other formula, that is V over current. You get? That is the formula for resistance. Therefore, resistance equals voltage, that is 12 divided by 2. Therefore, our resistance equals 6 ohms. That is how we find resistance using ohms law. Now, we are going to find voltage when we are given current and resistance. Please subscribe, don't miss ohms law. Just introduction, we are just starting the ohms law. We are on the introduction, so we are going to go deep with the calculations. Please put there your question if you have one. Put there in the comment, I'll find it there, so I'll be able to answer it the way you understand. Yes, thank you so much. Subscribe, comment, share, liking. Eng Steve Electric.